Hello, everyone. Thank you for joining our webinar. Before I let my colleague Cătălin begin the presentation, just wanted to talk to you a bit about how this webinar will go on today. So Cătălin will hold his presentations, and if you have any questions or any issues you want to talk about, please write them down, because at the end of the webinar we will be having a Q&A session. In addition, because we want to make this webinar a bit more interactive with the participants as well, during the webinar we will have various questions regarding Spring Data and various topics we discussed during the webinar, and would be very happy if you could join and answer them. And in order to do this, I kindly ask you to please have your mobile phone ready, because the solutions we'll be using for this quiz requires that you have a mobile phone. So other than that, I wish you all a great webinar. Please remember the Q&A session will be at the end. And other than that, Cătălin, you can start your presentation. Thank you.
Hello, Alex. Thank you for the introduction. I am Cătălin Tudose. I am currently employed at Luxoft Romania as a Java and web technologies expert. Otherwise, I have other activities. I'm an author at Pluralsight and Manning. We are going to spend today together about 1 hour in order to discuss a few important and remarkable things about Spring Data REST development, and we would like to make it efficient. So the title of the talk is Efficient Spring Data REST Development. In order to start, I would like to propose some first quiz, just to know where we start from. So this is the first question that is asked to you. We would like to know something about you before proceeding. We would like to know something about your experience with ORM frameworks. And this is what this question will be about. I think it will be soon shown.
Yes, so simply go to menti.com and input to menti.com on a browser on your phone, and just use that code up there.
The question is, which ORM framework do you use the most, if any? So most of you answered about JPA. We have people that haven't used any ORM framework before. That's still fine. You will be able to follow this. Of course, Spring Data is some advantage. Let me move to the presentation. And to introduce or to remind you a few things, we will say first what is REST. Representational state transfer. This REST is an acronym for this idea of representational state transfer. It is a software architectural style. It allows some interoperability between the internet and computer systems, and you would like to require access for the web resources represented as text. It has some well-known stateless operations. We have to define some conventions about using REST. We have to say that it is not protocol specific. Most widely used is REST over HTTP, but not absolutely necessary. The representation of the state can be in a few formats. Usual formats are JSON, HTML, XML. The convention is that the client uses the API to send to the server the URL to access, and the operation to perform on the resource. These are the well-known operations that I was talking about: get to retrieve some resource, post to write something, put to modify it, patch also to do some partial modification, and delete to remove it. Let's go to the code now. And I will introduce you to our application. It is a Java application that is using Spring Data and Spring Data REST. And it is a Spring Boot application. It was created with the dependencies of Spring Boot and introduced here. Spring Boot starter, what is important for us, and Spring Boot starter data JPA, Spring Boot data REST. These are the most important dependencies that we need in our application in order to be able to say, okay, we are doing Spring Data REST. In the background, we are going to use some in-memory database, H2, because we would like to be quick and not to be preoccupied what is happening inside the server. And the application is about working with some entities. We have two entities here that we define: the country entity, defined by code name and name, and the person entity, defined by name, some reference to the country. We have some information about the person, about having been registered and being some US citizen. What we have also to add is that we annotate these entities with this entity annotation. It tells us that they have some corresponding information in the database. That's why they are entities. As they have some corresponding information in some tables, they need some primary key, and that is why we are annotating this field with ID. And this field is self-generated by the database according to some strategies. So we use this generated value annotation. We don't have to care about anything about providing a value here, because the database will care for us. If we will start this application now, I'm going to go back to the code for some more explanations, but first let's see it in action. Okay, just a little. And we go to the browser here. I will access localhost 8081/persons. And I am provided this information that comes from the database. It arrives to the browser. Let's see how this happened. I go back here to the code, and I will look at some configurations of this application. First, we started the application on port 8081. By default, it will start on 8080, but we'd like to avoid the default. Sometimes it is busy, and we would like to have our own port dedicated to the application. You saw these entities that correspond to the table information in the database. What else? We start this application from here. This is a Spring Boot application. And we have to register here some beans. Beans are some, it's a notion specific to Spring. Whenever we start this application, as we have this these beans annotated with this bean annotation, it means that Spring will create them. You see, it will configure the repository by browsing some maps of persons and countries and populating the country and the person tables. This room is injected. We say that we have some persons in a room, and it is taken from this CSV data loader. You see, we create here some information. We take from a CSV file, and we build this room populated with persons. Persons have some countries. Where do we take this information from? It is here. So we made sure that when the application is started, we have the information corresponding to these persons. It is automatically done by Spring by the Spring Boot application, as it has these two auto-wired beans here, and we are importing this CSV loader that in turn also contains the countries map bean and the room bean. Okay, so we started the application. We got the database populated. We would like now to bring it to the front end. In order to arrive with it to the front end, we inserted here what we call controllers. This controller is a part of the MVC model view controller pattern. And you see it has to be annotated with REST controller. And we inject here some person repository. And whenever we access these IDs, these URLs, we delegate our execution to the repository to say, find all persons, save person, do whatever you would like to do. If we would like to check how our application is working, first, we have this interaction with the application through the browser, but we are also able to do it from within here, from within the IntelliJ, by directly executing these kind of commands. So you recognize here the verbs get, patch, whatever that we presented, we introduced at the beginning of our discussion about REST. So here, get everything that is at this URL. And if we execute it here, we will see that we will get here inside the application the whole bunch of persons. Here, I may get one person in particular. And so on, I may go to patch some information, to delete, to post. Let's add somebody new here, for example. And you see we have information about the introduction of this new person. Response code is 201. This means created. So on the side of the server, the record has been created. Let's verify here. We had persons from 0 to 19. If I refresh it here, we have persons from 0 to 20. So this John Smith was additionally added. Okay, These are the basics of the REST idea, but we would like to do more. We would like to be more efficient. One thing that I would remark here when I introduce these REST controllers, you see that we write some code here, auto-wired some beans and delegated to the repository to do a few things. There are many situations when this code is just delegating to the repository. So find all delegates to this find all, create delegates to save, and we may ask ourselves, what if we don't have this delegation? I will stop here the application, and I will simply remove this person controller from here. And restart the application. To see what is happening and to explain exactly why. No, I have to restart, just a moment. I have to restart the application, not to re-execute that post. Just a few seconds so that it restarts. Okay, it started, and if I access the URL from here, you see it is providing us the list of persons together with some links about how to navigate inside the collection, because it is very possible that you do not always know about how to navigate between these links. So what happened? The classical way to do controllers was, as I was demonstrating with the help of this REST controller annotation. And you have to do some code. And I was saying that some of the code may be boilerplate. You just delegate. Spring Data REST comes with this idea of providing such a repository. And if we don't provide any controller, it will simply expose the functionality of this repository to be provided here at the level of the front end, together with some links in order to allow us to navigate between the links to access the information from the database. So Spring Data REST will allow us to quickly write, you may write no code at all for the controller. In fact, what is happening here is that I may add here some annotation saying repository REST resource persons. I may annotate this with repository REST resource path equals persons. I will have the same effect, because without the annotation, Spring Data REST will see, okay, you are managing a person entity. So if you are managing a person entity, I will know that I will have to expose this repository through the default persons path. I may insert it here, or I may not insert here. I will insert it here now for the convenience. And if we have another look here, you see we are in the same situations. So we are now more efficient. We may shorten the code by removing this controller. We may still use our own controller if we would like to do some very particular operations. But in many situations, your first concern will be to provide some access directly to the repository. So you will be happy with exposing this person repository directly by Spring Data REST. If we take a look here at these commands, would like to demonstrate something else. I would like to get here this information about person with ID 4, and I am getting it here, you see, and I may still execute it again, and I will get the same information. Response code 200 is okay, but this may be still a waste of time for the communication, because if you are looking here, say I may get this person again and again and again, but the person, maybe it didn't change between these calls. Why to retrieve it again? It is a waste of time. In order to help us manage situations of this kind and to help us be more efficient, we have this usage of e-tags. In order to be able to introduce e-tags in our Spring Data REST application, we have to go here and to add this shallow e-tag header filter. You see here this bin, e-tag bin, and we have to register it here through this other bin. And once we have these things here introduced in our Spring Data REST application, we can work with e-tags. So what are they good for? E-tags are good for allowing us to know that a resource was changed or it was not changed. Because if it was not changed, you may say, don't give it back to me, just tell me not changed, and that's all. And I may go here and I take this e-tag from here that I had previously obtained when I first retrieved that person. I say, give me this person, number 4, only if the e-tag does not match the e-tag that I give you. You see, response body is empty because Spring Data REST knows that the resource was not changed. It is also providing this response code 304. It means exactly unmodified, and you will reduce the traffic across the network. We would like to be more efficient. We go here with if none match. It works fine. For the moment, this if match is for the moment not supported by this shallow e-tag header filter. The usage case of if none match is that you would like to check if some resource that was already there changed meantime in order not to retrieve again. The usage case of this if match, when it will also be supported by Spring Data REST, will be, I have some changes. I would like to know that on that side, the resource didn't change in order to add something more there or to change it. But for the moment, I was saying not supported. So this is the usage, and these are the benefits of using this E tag that comes as a response header in the HTTP. We would like, I was saying, to be more efficient. We don't want to load the network with many information. And we efficiently control the data to be retrieved. This is one good point. We would like to do more in order to be efficient. And we may say, if something happens inside our application, we would like to come and have some side action. You may be familiar with the observer pattern. So something happens on the subject, and some observers need to be informed and need to react to this. We have this possibility to do things of this kind with Spring Data REST. We have, in fact, two possibilities: to write an annotated handler or to write an application listener. Let's see how they look like. I moved here to some other version of the application. We still have to deal with persons and countries whatsoever, but we would like, I was saying, to come with some side effects. I was saying that we may write a handler or we may write a listener. Let's see how they look like, how they differ from each other, which are the use cases, when to prefer each other, which are the advantages of them. Here, I have a handler. In order to make it a handler, I have to annotate it with repository event handler, and for different events, we say handler before create, handler after create, handler before delete, handler after delete. You see that this handler works only through annotations. Annotation at the level of the class, annotations at the level of the methods. The annotations are self-explanatory. The listener needs to extend this abstract repository event listener and eventually to override some of these methods. You see, there is already this class here that has this empty methods. We would like to, if needed, we would like to override before create, on after create, and so on. And let's see how things are going. Let me first stop that old application so that I can start the new one. It will take a few seconds, as you know. It will still populate the database with the same records, with persons having some countries. Let's wait a few seconds. And then I will demonstrate how these side effects are managed by the handler and by the listener. Okay, it started. I go here to this command rest, and I say, let's post some new person. What we care about here is what the application does. And you see here, these are the messages coming from the handler before, listener before, handler before, handler after, listener after. Just some messages to demonstrate that the handler and the listener reacted. And for the delete, the same for more messages before handler before deletion, listener before deletion, handler after deletion, listener after deletion. So you see, we have these two possibilities. Which one to prefer? I may give some personal opinion. If it will be my choice, I will go by handler because it goes only through annotations. When I go here, I have to, with listener, I need to extend a class. So I am hanged there in some classes hierarchy. But with handler, I go fully at the level of annotations. Annotations mean meta information. And consequently, we don't need any connection to any class. You may still consider that listener extending some class may be more clear for somebody that is working with the application. If this is your point of view, go with listener. I would go by the level of meta information through annotations. All right. Let's do something more in order to be efficient. And I will move to the next demonstration here. It is about using what we call heteros. Let me start it. As you know, it takes a few seconds. You remember at some time we this remained here, and we demonstrated that at the time when we introduced that directly that repository that exposes its functionality, we got this help to be able to navigate between the links. I have here this application that has usual controllers, as we were saying. And we would like to access and see how it goes. Persons, localhost, local host 8081/persons. We have here our information, but without the links. Why? Because we are now using a usual REST controller, as we were previously doing. Maybe we have an older application. Maybe we would like here to expose some very particular operations that cannot only be forwarded to the repository itself. And we still want to take the benefit of being instructed about how to navigate inside the application. Here, this heteros states for Hypermedia as the engine of the application. Let me show you here something. So Hypermedia as the engine of application state. It didn't come from the very beginning so nicely. At the very beginning, people were using what it was called plain old XML. Plain old XML meant that you were able to send any XML to the server and you were expecting the response in any format. But this was very heterogeneous and we would like to be more efficient and more standardized. Here, where in what we see here, Richardson maturity model, we see level 1 introduction of resources. So as you are accessing that URIs, they are our resources, but we would like to access them in some standard way. And we introduce these standard HTTP verbs, get, post, put, delete, so that we can handle similar situations in a similar way. That was good, but here we come with level 3, Richardson maturity model, about the self-documenting API. We may still do, in the absence of those self-exposing repositories, through this HTOS. That was the idea. And going back to our demonstration, we say, let's expose some different information, but in this URL. So I go here. Just a moment. Localhost 8081 API persons. So you see that we see again this helping hand, this time from the side of HTOS, that will allow us to quickly navigate between the resources. Let me see how I can. Okay, all right. You see, I am accessing here person number 7 directly through this link. A big advantage as we were providing previously. When still to use HTOS, what to do to use HTOS, we have to add some dependencies in our POM XML here, you see. And besides this, we need to write our own controller to add it, to annotate it with this particular annotation and to provide some particular operation to delegate to this person model assembler. You see here, I will have a quick look at this person model assembler component that is taking care of providing the additional links that help us navigate. When to use HTOS, you may still prefer to use HTOS when you have to write some own particular controller to do some particular things, and you would like to avoid simple delegation to the functionality that the repositories, the Spring Data repositories already expose. Okay, it's time now for another quiz, for 2 more questions.
Sorry, Catalin, before you start, because I think we had some people that that joined us. I think before you, actually after we did the first question. So for those that joined us after we asked the first question, so just take your mobile phones and use the browser and go to www.menti.com. You see it there at the beginning of your slide, and just insert that code 11762199, and then you'll have access to this platform and you'll be able to answer the questions. So I think if we give like 10 seconds and then we can start.
Okay, I should press here
Yeah,
The
you can
mouse
press. You
button.
can press the next one. Yeah. Let's see if it works. If not, I think you can start it again. It's not a problem.
If I refresh it, let's see what's displayed here. Okay,
This is the first one, and then
the first,
yeah.
and if I press enter or if I click the button, nothing happens.
Okay, so yes, it seems to be a bug from our end. So I think that you just continue with the presentation, and I'll see if I can solve it. Thank you.
Okay, please go ahead. We may go back to these quizzes a little later. Let's focus on how we can be also efficient, other possibilities to improve the efficiency of our Spring Data REST application, projects and excerpts. What is it about? We say here that Spring Data REST presents a default view of the domain model you export. So the default view is I provide you this information and you can always see it, but sometimes you need to alter the view. So I will give you only this information, or I will aggregate some information. I will combine some columns. Very frequently, you would like to do this. Let me close it, move to this next. We'd like to introduce what's called projection. And for this information about the persons, we will say, okay, let's provide some possibilities for this projection. So we write this interface person projection, say, I will call it summary, and it deals with persons. I will expose only first name and last name, and gender will not be exposed, while for this address field, I will not provide it just like this street on different fields, but I will combine it. How? According to this toString method. So it is this toString method from the address class, and it will nicely display us the information. And I will say, okay, would like to do some information, provide some information to this repository, use this person projection in order to expose the information. Let's start it, the application, and we'll demonstrate both how it will work with full information and how it will work with projection. Here, just to mention, because I haven't mentioned this, this is called Spring Expression Language. So we annotate here with value, and we provide here an expression language. Okay, let's see this in the browser. Directly here. First, without the projections, you see we provide full information here. We provide this address through 4 fields. And here, through this projection summary, you see we do not expose the gender any longer, and we show this address in this format. What's the use case of projections? Of course, when you would like to provide some particular information to your clients. Somebody is interested by something, somebody is interested by something else, or maybe they are not allowed to see everything. Or they would like to see something in a nicely formatted way. It is very flexible. And you have this possibility to provide something nice, to do something particular for your client. Let's see if this one was corrected. Okay, let's see here some question. Yes, it runs now. I will provide 2 more questions now at the end of our demonstration, 2 more questions. So this is the question: which of the following operations is used in REST architectural style to retrieve a resource? A simple question, I would say. Time's up. Let's see. Everyone knows, of course, that GET is the REST operation that is used to retrieve the resource. And one more question for now. About the role of the e-tags. Which of the following describes the target functionality of e-tags? Correct answer is determine change content at a URL. I see that the large majority of you opted for this answer. Remember, we have e-tags that tell us something changed or something didn't change on the side of the server. Okay, I go back to the presentation. We'll have 2 more questions at the very end. We just want to introduce here something about reactive access to repositories. What is reactive? Reactive means that we are able to efficiently retrieve some results, but as a stream. If you interact with your database from Java, in most cases, you are going to interact through JDBC. This is the classical way of interacting with the database. It has a disadvantage. It comes from the old times. It is blocking. So you are blocked there to interact with the database. But there are situations when you would like to see that some data is already flowing to you from the early stages. Imagine that you go to Google and try to search something. You would like to see quickly a few results on your site. Going reactive will help us retrieving the results as a stream. So the information will flow to us and it will quickly provide us the very first pieces. There are some equivalent types of repositories. Instead of CRUD repository, the classical way, we have reactive CRUD repository. Instead of JPA repository, we have R2 DBC repositories. Let's see them in action. I will stop this, and we still have one more example here. I will start this, and meantime, I will have to start some other browser, and I will explain you why. The reactive application is starting. The reactive way of working is pretty new, and not everyone is supporting it. And I will demonstrate how the support is in a few situations. The application is starting. I will let you know that I chose this one, Google Chrome, and I'm opening it because it has some support for reactive Spring Data, and I will use it to demonstrate it. I started here this application, and if I go here and say give me all persons, get, you see it is providing them at once. If I see here, give me persons as a stream, it is not displaying anything. We are waiting a little, and we will soon get some information. You see, it lasted a little just to gather everything. Why? Because the IntelliJ IDEA client does not support yet reactivity. It is still blocked there. But let's try with this another client that is supporting reactivity. You see how data is flowing to us. So you will be able to quickly get the data, to quickly see that you have some information. Your clients will be happier because they already have something like in my example of Googling. And you may even start to process something else based on the first inputs. Say, okay, I am expecting some larger bunch of data, but as data is flowing to me, I can start to process John Smith. I will quickly process Jane Underwood, and they will flow to me. It is just you start to build a house, and you already have the first materials to start to dig into the foundation. For example, the materials that you need for your windows whatsoever may come at a later time. You are not blocked waiting for all the information. So this is an excellent use case for reactivity. Reactivity does not come only with advantages. I will emphasize here that you remember in our first application, I removed this person controller because I was saying that person repository is able to directly expose its functionality. However, this is not true in reactivity. If I remove here, it's not yet true, at least, because it is not supported. If I remove the explicit controller and I will say here repository rest resource path equals persons, and I will restart the application. Just, you know, it lasts a few seconds. Restarting. We would like to see how the reactive application acts when it does not have an explicit controller. Okay, starts in a few seconds, and I will immediately move here to our old URL. Say here we are getting some error message because does not work in a reactive way. See, I am accessing other URLs and still not working. It says I'm trying to cast some class that is specific to the reactive world to the iterable, which is old classic class in Java. They are not compatible at this time because reactive Spring REST for the moment does not support this exposure of repositories through this annotation, repository REST resource. So it comes with some advantage. It quickly provides you this information about data quickly. You get quickly the data, but you have to always write more code, not at your choice, as it was previously, to create this controller and to delegate its functionality to the repository. So I will restart this application. I think meantime, we may go to the next question because we are by the end. So there are two more questions. About the purpose of HTOS. Okay, we are getting closer. Time's up. The purpose of the HTOS is to dynamically provide information about the application through Hypermedia. Yes, most of you answered correctly. And one more question. About how Spring Data Reactive will retrieve the information from the server. Yes, everyone knows that information is retrieved as a stream. Very good. So I restarted here the reactive application. And if I go here, what happened? So it doesn't. I had to also do something. Okay, I will remake it, but meantime, let me show you something, because I saw a question about the access to the source code. You can get it here on my GitHub repository.
Catalin, I think it would be good if you can just copy paste your GitHub address in the chat, so
Yes.
so people can click on it.
Okay, and I will provide it here. And meantime, I remade this reactive application to see again that data is flowing to us and we can quickly start on working with it. So this is the plus. The minus is that you have to write always your own controller. So we are by the end of our presentation. I will display here. Thank you. And I'm looking forward for questions.
Thank you, Catalin, as well for your presentations. So before we move on to the Q&A session, just wanted to let you know that we will also be uploading the recording of this webinar on our YouTube channel. And we will include the link in the follow-up email. And another request from us is if you could please fill our feedback form. I just gave you the link to our form in the chat. It would really help us to improve our next webinars, to see what other subjects you would be interested in, so we can create webinars on them. And it would again really help us a lot to improve the experience. Other than that, until we close, let's open the session for any questions you might have. So just put them in the chat, and Catalin will answer.
I'm here, so I'm looking at possible questions. No questions so far. I answered everything from the beginning. It is true that our presentation took a little more than probably we were expecting. 45-50 minutes for presentation and 10 to 15 minutes for questions, but probably that difference meant that we have already answered some questions.
Yeah, it appears there are no questions from our participants. So thank you so much everyone for taking part, and keep close to your email clients so you can receive our follow-up email with the registration and the feedback form. Once again, just a kind reminder for everyone to, or as many as possible, to fill our feedback form so we can improve our future webinars. Catalin, thank you so much for the presentation.
Thank you so much.
Have a great day, everyone. Bye bye.